Hello and welcome to this first video of the GCSE Mathematics course. In this one we're going to look at section 1 in numbers, and in particular we're going to look at integers and rational and irrational numbers. So the first thing we introduce is integers. So integers are just a fancy name for a whole number. So a whole number is anything such as 1, 15, 1000, minus 50. These are numbers that do not have decimal places. So there are no decimals. So there's no, for example, 1.5 would not be an integer. They're either positive numbers, they can also be negative numbers. So for example, we've got here minus 50, we can have minus 1000, we can have minus 10 million. As an example of an integer. The key thing to remember about integers is they are whole numbers, there's no decimal places, there are no fractions, and there are no surds, and there are no square roots. Essentially, well, technically a square root can be, but we'll move on to that a little bit later. But there's no surds in particular, which we'll cover later. So we'll look at this in a later topic. So here's some more examples of integers. We've got 4, 543, minus 9, 0, 8, minus 839,320, and 430,393. They're all examples of different integers. One of the ones that might look a little bit different is 0. 0 is we take as a whole number. It is an integer. If we think about the number line, we go minus 2, minus 1, 0, 1, 2, 3, etc., etc. So 0 forms part of this chain. We treat it as an integer. Rational numbers is our next topic. So in rational numbers, there are numbers that can be essentially written as fractions. So if you can write a number as a fraction, you can call it a rational number. The obvious example here would be an integer. So 5 itself, 5, can also be written as 5 divided by 1. You do 5 divided by 1 on your calculator, or if you know already what it means you're just dividing it by 1, which means that you have 5 as your answer, which is an integer. We've got another example here with minus 12. Minus 12 divided by 1 is equal to minus 12. This is another example of a rational number. And even 0 is a rational number. If we put 0 at the top and we divide it by 3, 0 divided by 3 equals 0. It is an integer and therefore is also a rational number. The second one is obviously if they can be written as fractions, that means that fractions are obviously a rational number. So we've got a variety of fractions here, 7 over 4, minus 3 over 4, 1 over 3. If you see these as fractions, then you can treat them as a rational number. Even ones such as 1, 1 over 4, so these are mixed fractions. This is an example of a rational number. If we think about what this is simply 5 over 4 as a top-heavy fraction, or if you want to write it as a decimal, it is 1.25. This is an example of a rational number, so this is rational. We also finally have reoccurring decimals, which are decimals that continue on forever. If you do 1 over 3 on your calculator, you will get an answer of 0.33333333. Essentially, it continues on forever. These are examples of a rational number because you can write them as a fraction, 1 over 3. Another bit harder example is 0.564564564. If you notice here, 564 is repeated continually in this fraction. So it's 564 here, 564 here, 564 here. The next number in the sequence will be 564 and it will continue on and on and on. Now this is actually a fraction, 564 divided by 999. If you put that into your calculator, you'll get this as a result. So it is a case of a rational number from a fraction point of view, but also if you have a number that has reoccurring decimals, so it's recurring, then you have that is also taken as a rational number. So let's have a look at irrational numbers. So irrational numbers are essentially numbers that cannot be written as fractions. So an example of a non-repeating decimal is this example here, 1.25786476643. with the dot 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 at the end of it, that means in this course it means it will continue forever, and it does not repeat as a pattern. So these numbers are essentially almost randomly seeming numbers put together, and in this case this is an irrational number, so we say that this is irrational. The most common number that is like this is pi. Now pi, the value of pi, if you plug this into your calculator, you will get a really long number of 3.141592654. However, that is not the end of pi. Pi is limitless. Pi, there are hundreds and hundreds of digits of pi, and it's a never-ending number. We call this an infinite number. In terms of decimals, there's always one more number, one more decimal place that we can go down. So 3.141592654, etc., etc., etc. So we call this another example of an irrational number. The tricky example is with square roots. So square roots can be irrational or rational. A square root is rational when the result is an integer. So here, if you do the square root of 4, if you put it on your calculator, you'll get 2, or you might know that already. This is an example of a rational number because you get an integer as a result. Another example, the square root of 25 is equal to 5. This is another example of a square root, the number inside of the square root. If you plug it into your calculator and find the result, you get 5. When it's irrational is when the result is not an integer. So for example, the square root of 2 is equal to 1.41421356, etc. This is not an integer, and even though in your calculator this digit stops, we treat these numbers that when there is a square root and the result is not an integer, we call this an irrational number. Another example here, square root of 7. If you plug it in, that will not give you an integer as an answer, and therefore it's irrational. Obviously, later in the course, you're going to come across surds. So this is an example of a surd, 3 root 2. So it's a square root with a number outside of it multiplying. These are irrational, and the reason why they're irrational, if you come back to it, is that square root 2 is irrational number. So therefore, the surd itself has to be irrational because of the square root 2. That's the end of this course. I recommend that you do the problem sheet and try out the questions. Thank you for listening.